Imagine a world where every hand gesture resonates with the power of speech. Our groundbreaking project, Sign Language Detection to Speech Recognition, is transforming this vision into reality. Millions face communication barriers, but we're here to change that. Using advanced AI and machine learning, our system captures hand movements and interprets them into spoken words in real time. It's not just about recognizing gestures, it's about stacking them into meaningful sentences, creating a seamless conversation. Picture a classroom where hearing and non-hearing students engage effortlessly, or a healthcare setting where patients can communicate their needs without barriers. This technology empowers the differently abled community, enhancing accessibility and inclusion in every aspect of life. We're not just building a tool, we're building bridges across communication gaps. Together, we're making communication universal, amplifying voices that deserve to be heard.
Hello everyone, I am J. Suchita and I am here to present our project titled A Novel Technique for Hand Gesture to Speech and Text Recognition using Industry 4.0 application under the supervision of Mr. G. Sunil Reddy, Assistant Professor, along with my team members Srivardhan Rao, Pavan Kumar, Ritvik Reddy and Srija. To the abstract of my project. In the real time of human-computer interaction, the translation of hand gestures into speech and text presents an innovative approach to bridging communication gaps, particularly for individuals with speech impairments or those who rely on sign language. This paper introduces a novel technique for hand gesture recognition, leveraging advanced machine learning algorithms and sophisticated computer vision technologies. By capturing and analyzing hand movements through depth sensing cameras and motion sensors, the system extracts unique features such as shape, motion, and temporal patterns. These features are processed using convolutional neural networks and recurrent neural networks to classify gestures accurately. The recognized gestures are then mapped to corresponding speech and text outputs, facilitated by text-to-speech synthesis. The proposed system demonstrates significant improvements in accuracy and efficiency over existing methods, showcasing its potential in various applications including assistive technologies, healthcare, and interactive educational tools. This technique not only enhances accessibility but also opens new avenues for intuitive and naturalistic human-computer interactions.
Today's technologies has profoundly transformed the landscape of human-computer interaction, a new era of accessibility and communication. The conversion of hand gestures to speech and text stands as a remarkable advancement, addressing the communication challenges faced by the speech-impaired people and the people those who rely on sign language. By employing advanced feature extraction methods like deep learning algorithms, this system converts the gestures to speech. This output is possible by using text to speech synthesis. The existing methods, detecting hands and drawing. The tools like OpenCV and MediaPipe are used for detecting the hand and drawing trajectories. Other mode of communication like censored glosses. This system uses wearable glosses which track movement of the hands, converts them to text. Converting gestures to text. Focusing on converting gestures to text involves recognizing static and dynamic gestures and mapping them to corresponding text.
Hi, I'm Ritvik, and let's see how this technology works. There are 5 major steps here, and I'll be taking you through each step now. Step 1. Data collection and pre-processing. It starts with gathering a diverse collection of hand gestures and assigning it to each word or a phrase. And then we have pre-processing part, removing the background by using techniques like skin tone detection or background subtraction. To make sure the system is accurate, we normalize the gesture by adjusting features, hand sizes and position. And then we have step 2, it is gesture recognition. Once the data is ready, we extract features by identifying key points on the hand and fingers using tools like MediaPipe. And for static gestures, we use deep learning techniques like CNNs, that is convolutional neural networks, to do the classification. And we have step 3, mapping gestures to text. This is where the magic happens because gestures are converted to text, and some gestures can represent single words and some can represent multiple words, and these can combine make some phrases. To make sense of it all, we have to, or we can use language models like BERT or GPT, which can analyze context to ensure the translations are accurate, even more for complex sequences. After mapping gestures, we have to convert the gestures to speech, and that is where the important part. Step 4, gesture to speech conversion. Once we have the text, it's time to give it a voice. Text to speech systems like Tacotron or fast speech generate neutral, natural, human like speech that sounds clear, expressive, and also easy to understand. Then we have step 5, real time processing. Real time processing is crucial for a seamless experience. Real time video streaming also uses tools like TensorFlow and OpenCV to make sure that the system works smoothly on mobile or embedded systems. With low latency, the system translates gestures to text and speech almost instantly, and after it detects no hands in the frame, it's going to stop. In conclusion, the technology has so many possibilities, from assistive devices that empower people with disabilities and the new ways of interacting with computers. It's all about breaking barriers and making communication accessible to everyone and each and everyone in the world.
Coming to algorithm, firstly input capture. There will be a camera access to capture real-time hand gestures. Like if we keep the hand in front of the camera, first it will capture the hand, and next it pre-process, means detecting the hand using the hand detection model. That is called media pipe example. So it is also called as extraction of region of interest. This is called like region of interest. So it will just detect the hand. And feature extraction, like resizing or grayscale, resizing the exact hand shape, and it finds the correct recognition of gesture. And gesture recognition, using a trained model by using CNN or deep learning model, it classifies the gesture through what we gave in the frames. So, and finally output generation, mapping the recognized gestures to the what we gave in the frame, and it shows the what kind of gestures we are giving. And finally it displays an text and audio, so displaying the text on the screen, and it also generates the corresponding speech according to the hand gesture. This is what the algorithm from the first step to last step. Finally, coming to results, here we can see GTS, gestures to speech. It's a brand, or it's the name of our project. So the output of the code will get start and the stop. So when we go with the green button start, here we'll get
No, please, hello, hello, I love you.
I think you can hear some noise. See, that is the voice recognition. So here are the results. This is called the region of interest. The green color box with the hand gesture is called region of interest, and it recognizes the hand gesture and it pre-processes and it gives the correct gesture text, and also it gives the audio of the text. So this is what the main theme of the project.
My name is Srija. I'm here to explain the future scope of these projects. So the first point that we have here is sign language interpretation. This technology allows for the real-time translation of sign language into spoken or written words. It helps to bridge the communication gap between the deaf and dumb, those who don't know the sign language, improving daily interaction. So next point is human-computer interaction. Gesture-based interfaces make it easier to control devices like smartphones, computers, and smart home systems without physical touch. It allows a natural way of interacting with technology. Healthcare applications. In healthcare, gesture recognition aids rehabilitation and supports non-verbal communication in surgeries. Entertainment and gaming. In virtual reality and augmented reality, gestures are used to interact with digital environments, manipulate virtual objects, and enhance the gaming experience. This makes the experience more immersive and enjoyable through motion-based controls. The thing that we have here is robotic and automation. Gesture recognition enables people to control robots and automated systems with their hands, making it easier to manage tasks in industries like manufacturing, logistics, and service automation, all without the need for physical contact. In all areas, gesture technology is making communication and interaction more seamless, efficient, and inclusive. Finally, I just want to conclude that the ability to translate hand gestures into complete sentences has huge potential to change the way we communicate and interact with technology. It can bridge the gap between the non-verbal and spoken communication, making it easier for people in deaf and dumb people to connect with others. This technology also have power to enhance virtual experiences and improve productivity in areas like healthcare, education, and robotics. Technology continues to improve, particularly with advancements in AI, machine learning, and sensors. Gesture recognition systems will become an everyday part of life. They will open up new possibilities for both individuals and industries. Gesture recognition will help create more natural, efficient interactions between people and machines. This technology has a bright future. As it develops, it will make communication and user experiences for better for everyone.